Welcome to math classes. Today we'll see some critical questions for limits, mainly JEE and BITSAT focus. And the important concept we will learn in this video is Taylor series. Okay, what is Taylor series? Some important series and how to apply them. Using the PYQs, we will see some questions how to apply these Taylor series methods. Okay, so let's get into the questions. Yeah, in a function f of x is defined as given here for x equal to less than 0, x equal to 0, and x is greater than 0. Okay. Uh, then it is mentioned that it is continuous at x equal to 0, then what is the value of k1 square plus k2 square? We have solved several of such problems actually. All these problems are very simple. Once they are given it is continuous at x equal to 0, you consider LHL equal to RHL equal to f of 0. Okay, this is most important. So, and derive what are the values which are variables from this. Okay, so first let us see the LHL. LHL is nothing but limit extends to 0 minus. 0 minus means x is negative, so I should take this function definition, correct? So 2 by x into sine k plus 1x plus sine k2 minus 1 x. Okay, so which I can rewrite this in this form. Okay, take x as a denominator here. So it is in the form of sine x by x form actually. Okay, so limit extends to 0, sin x by x is 1. So if I take this as two separate terms basically, 2 times sine k1 plus 1 x by x and 2 times sine k2 minus 1 x by x. Okay, the value is 2 times k plus 1 plus k2 k1 plus 1 plus k2 minus 1. Okay, which is nothing but equal to 4, because this is RHL is equal to f of 0, which is 4. Okay, so from this I can derive one equation which is k1 plus k2, which is equal to 2. Okay, second I take the RHL. RHL means limit extends to 0 plus means x is greater than 0, so I will take this expression. Okay, this is nothing but 2 by x ln log e, uh, 2 plus k1x divided by 2 plus k2x. Okay, now this one is also simple. Okay, I will expand the log as the log 2 plus k1x minus log 2 plus k2x. Okay, now I know that there is a one formula which we use for the log actually. Log 1 plus ax by x is equal to a, right? So we use that one, same thing here. So if I take log 2 common from this one, it will become 1 plus ln 2 if I take common, it will become 1 plus k1x by 2. Okay, ln 2 times 1 plus k2 by x, remaining all same. This I can write, there is the product of ln 2 into something, right? So I can make it as 2 plus this value. Okay, here 2 plus this value. That way I will cancel ln 2 actually. I am left with a limit extends to 0 plus 2 times ln of 1 plus k1 by 2x minus ln of 1 plus k2x by 2 divided by x. Now the formula I use is this one. Limit extends to 0 plus ln of 1 plus ax by x equal to a. Okay, so here since there is a k1 by 2, so I will get k1 by 2. Okay, and k1 k2 by 2, which is k2 by 2 minus sign and 2 times. Okay, so which means if I simplify, I get my second equation, which is k1 minus k2 equal to 4. From these two equations I can get my k1 k2, which is nothing but 3 and 4. So k1 square plus k2 square is nothing but 10. That's the answer. Okay, so now let's learn some concepts. Okay, this is about the Taylor series. What is Taylor series? Some important series, and then we solve some problems on this one. Okay. Okay, this is mainly we are not going to derive Taylor series. Okay, that is for your higher classes where you will derive Taylor series and Maclaurin series. But first, understand how to use it. Actually, what is the formula? How to use it? Okay. So Taylor series is a way to represent a function as an infinite sum of terms derived from the derivatives at a single point. Okay. So this is the main definition. If I call f of x as a function, I can call it as f of a plus f dash a times x minus a plus f double dash a. F dash a is nothing but first derivation of f of x at x equal to a. Okay, this is second derivation of f of x at x equal to a. Okay, so f double dash a into x minus a whole square by 2 factorial plus f triple dash a, okay, x minus a whole cube by 3 factorial. See the similarity. First one is f of a. Okay, then you have one derivation and into x minus a by 1 factorial, you can call it. Okay, second one is second derivation x minus a whole square and by 2 factorial. Third derivation x minus a whole cube by 3 factorial. Okay, this is the infinite series. It will go on like this. Okay, because some terms will be there. Suppose if you take e to the power of x, any number of times you apply derivation, you will get e power x. Okay, there is no end to it. But if you take x square, after the second derivation, it will become 0. Correct? So you will have only two terms in that case. Okay, but some terms will have infinitely, it will go on. So that's why Taylor has defined a series like this. The most important part of this one is application of this one is Maclaurin series. Okay, so Maclaurin basically improved it by saying at a equal to 0, you can actually get very interesting series. Okay, so f of x will become at a equal to 0, f of 0 plus f dash 0 x. Okay, because a is 0, right? Then f double dash 0 x square by 2 factorial, f triple dash 0 by x cube by 3 factorial, and so on. Okay, now using this we can derive several infinite series actually, and we can use in limits very not only limits, you can apply it anywhere actually if you want. Okay, and only one thing is, you remember this is only approximation, it's an infinite series, so you don't know how many terms you will consider, right? So wherever you are stopping, basically you are getting a approximation. Okay, this is the improved approximation Maclaurin series is. Okay, so some important Maclaurin series expansions are here. E to the power of x is equal to, you just need to substitute, go back. Okay, f of 0 is e to the power of x, x dash, this is also e to the power of x, e to the power of x, e to the power of x, right? So you will get 1 plus x squared by 2 factorial plus x cube by 3 factorial, and so on. Okay, this is for all x. Sin x is defined like x minus x cube by 3 factorial plus x to the power of 5y factorial minus x to the power of 7 by 7 factorial, and so on. Cos x is basically you get the in between terms, okay, the missing terms. 1, okay, minus x squared by 2 factorial plus x power 4 factorial minus. So if you remember one of them, other one is easy. Okay, so you have to do it like this. Tan x is nothing but x plus x cube by 3 plus 2 by 15 x to the power of 5, and so on. And for tan x, the angle is limited actually. The angle is between minus pi by 2 to pi by 2. Okay, and ln of 1 plus x is nothing but x minus x square by 2 plus x cube by 3 minus x to the power of 4 by x to the power of 4 by 4, and so on. Okay, in this case x is between minus 1 to 1. Okay, now 1 plus x whole to the power of n defined here. Okay, and so on. 1 by 1 plus 1 by 1 minus x defined here. Okay, arc tan x, arc sin x. So there are so many of them. Okay, uh, most of them are, everything is useful, but you have to remember so many equations. So best way is only the complex ones you remember, and other ones you can derive easily from the definition of Maclaurin series. Okay, so now we will use these things in the limits. Okay, all these values will use them in the limits. Okay, so let's do that next. Yeah, this is a BITSAT question, which is a straightforward substitution of a Taylor series actually. Okay, the value of limit extends to 0, 1 plus x whole to the power of 1 by x minus e plus ex by 2 divided by x square. Okay, now let's see if you can apply L'Hospital rule. Okay, L'Hospital rule, if you apply on 1 plus x whole to the power of 1 by x is very difficult actually. Okay, so simplest way is to substitute the Taylor series form. Okay, so Taylor series is uh, for this 1 plus x whole to the power of 1 by x is e minus e by 2 plus x plus 11 e by 24 x square, and it keeps going on, okay, with x cube and so on. So one important thing you should know is how many terms you should take. Okay, so you should take as many terms as you have the highest power of denominator. Okay, so highest power of denominator is x square, so you need terms up to x square, that's it. Okay, other things you don't require actually. Okay, you don't need to remember. So most of the cases you may have to remember up to x square or x cube, that's it. Okay, uh, one important thing is 1 plus x whole to the power of 1 by x derivation from Taylor series is very difficult. So I think you don't need to try to attempt this one. This is one formula you should remember. Other things you can derive: sin x, cos x, e power x, log x, everything you can derive easily. Yeah, but whichever is difficult to derive, you remember it. Okay. Now once you know this is the substitution. So my limit. This function will become 1 plus x whole power 1 by x minus e plus ex by 2 divided by x square will become, if I replace Taylor series here. Okay, e and minus e cancel, minus ex by 2 plus ex by 2 cancel, so I am left with only this one, and divided by x square, so that is nothing but 11e by 24 plus or minus whatever function of x cube by x square. Okay, now here always I get one x term, correct? So when limit extends to 0, when I apply, okay, This is constant term which is out there, and here always I have one x term, so it will become 0. So the answer is 11e by 24. That's the answer of this one. So this is a example of a problem which is a straightforward substitution of Taylor series. Okay. So this is how you can take advantage of Taylor series. Okay. Yeah. Next. Limit x tends to 0, cos 2x plus a cos 4x minus b divided by x to the power of 4 is finite, means defined. Then what is a plus b? Because this is one problem, you can actually use El Hospital rule and solve it. Okay, it will go, you have to take up to almost 3 to 4 derivations you have to take, numerator and denominator. But that is not a big deal, you can actually do it. Okay, but it is easy if you do it with Taylor series, because one shot you will get the two equations to solve a and b. Okay, let's see how to do this. Okay, so cos 2x, cos x, you just need to replace x with 2x. Cos 2x Taylor series is 1 minus 2x square by 2 factorial plus 2x to the power of 4 by 4 factorial and so on. Okay, as I said, how many terms you have to take? Up to the highest power of denominator, which is 4. So x to the power of 4 I should take. Okay, similarly cos 4x is 1 minus 4x whole square by 2 factorial plus 4x to the power of 4 by 4 factorial and so on. Okay, now if I substitute these two, this is my given function. Okay, so my function will become, okay, 1 minus this expansion here, cos 2x expansion, cos 4x expansion, okay, a times cos 4x expansion minus b. Okay, and this is defined, which means, okay, all the terms which have x in this will become 0, which is after x to the power of 4. Okay, in this expansion, okay, this will become 0, so ignore them. Remaining terms won't become 0 actually. Okay, remain, because x power 4 is there, they get cancelled or they are undefined. You will get, in this case, you will get 1 by x square in this case. Okay, so what is the meaning of, since the limit is defined, these terms also should be equal to 0. Correct? So you take the terms one by one and make them equal to 0. Here, one constant term is 1. Okay, so this will become 1 by x power coefficient, right? Okay, so this is 1 by x power 4 minus 2 square by x square 2 factorial plus 2 to the power of 4 by 4 factorial minus order of other x to the power of 8 or so, whatever. Okay, similarly a times this one and minus. So here you take the terms carefully. First we'll take the quotients of 1 by x power 4, because some of them should be equal to 0. Here it is 1 plus a minus b. Correct? 1 plus a minus b equal to 0. Okay, so this you will get one equation. Second equation is x square terms you take. So 2 square by 2 factorial, which is 2 by x square, right? So this is 2 by x. Okay, minus 2 square by 2 factorial minus a times 4 square, which is nothing but 2 to the power of 4 by 2 factorial, which is equal to 0. Okay, there is no other term. So from this one, I can derive a equal to minus 1 by 4. So if I substitute here, I get my b equal to 3 by 4. Okay, so my a plus b is nothing but 1 by 2. That's the answer. Okay. So hope you understood how to solve this problem simply using Taylor series. Okay, and remembering cos x is not so difficult, as well as deriving cos x also very easy. So if you remember the definition of Taylor series, you can derive it in a minute actually. It's not a big deal. Okay, next. If the function f of x is equal to tan of tan x minus sin x divided by tan x minus sin x, where x is not equal to 0, is continuous at x equal to 0. It's given. Okay, then find the value of f of 0. Okay, so this is a very difficult if you want to apply a L'Hospital rule, correct? So this is a fantastic question to solve using the Taylor series. Now, first remember the Taylor series expansions. Tan x is nothing but x plus x cube by 3 plus, I need up to x cube only, that's enough actually. It's not, if you look at the denominator, it is just a tan x minus sin x, okay? Plus order of whatever x power 5 and so on. Sin x is nothing but x minus x cube by 3 factorial plus order of x cube, okay? Some function of x cube, x power 5. Okay, and my tan x minus sin x is nothing but x cube by 2 plus order of, I'm just subtracting this series, and plus some function of x to the power of 5. Okay, so my tan of tan x is nothing but tan of tan x is nothing but tan x plus tan cube x by 3 plus some order of tan to the power of 5x, correct? So my sin of sin x also defined here using Taylor series. Now all these are defined using Taylor series. Now I just substitute them and see what happens. Okay, so limit x tends to 0, f of x is nothing but tan x minus sin x plus tan cube x by 3 plus sin cube x by 6 plus the remaining infinite order of functions. Okay, functions divided by x cube by 3 plus order of x to the power of 5. Okay, now what I'm interested is I need to basically get the sin x by x or tan x by x format so that they will become non-zeros. Okay, that's the only thing I'm looking at. Okay, so divide the numerator and denominator with x cube, because x cube is the power in the denominator, correct? So when I divide it, this is what it will become. Limit x tends to 0, tan x minus sin x by x cube plus tan cube x by 3x cube plus sin cube x by 6x cube plus some function which will anyway will become 0 because there is a x term, multiplication of x or tan x or sin x, which will become 0. Okay, so I'm not interested in this one. Divided by 1 by 2. Okay, because x cube has gone here. So 1 by 2 plus some order of x square, which will become 0 anyway. Okay, so now I know that this is tan x by limit x tends to 0, tan x by x is 1. Limit x tends to 0, sin x by x is also 1. So this is 1 by 3, this is 1 by 6. I need to solve this separately and put the value here. That's it. Okay, so I need to put the tan x minus sin x by x cube value separately. I should solve with limit x tends to 0 and substitute here. Let's do that separately. So limit x tends to 0, tan x by minus sin x by x cube is nothing but, I take sin x common, so it will become 1 minus cos x minus 1 divided by x cube. Okay, which is nothing but 1 minus cos x by cos x. Okay, so 1 minus cos x, I can write it as 2 sin square x by 2. So it will become sin x into 2 sin square x by 2 divided by cos x by x cube. Now I have 3 sin x terms here and x cube here, so it will become easy, right? So I can rewrite this as limit x tends to 0, sin x by x, sin square x by 2 by x square by 4. So I have my x cube and I added divided by 4, so I am multiplying with 4 in the denominator. Okay, into 1 by cos x, 2 is already there, so 2 by 4. Okay, now this is 1. Okay, this is 1. Cos x equal to 0 is also 1. This is 1. So the answer is 2 by 4, which is nothing but 1 by 2. Okay, so if I substitute this 1 by 2 here, okay, my limit extends to 0, f of x will become 1 by 2 plus 1 by 3 plus 1 by 6 divided by 1 by 2, which is nothing but 2. That's the answer. Okay, so this is a classic example of using Taylor series. This is, I think, very difficult to solve using L'Hospital rule or any other rule. Okay, next. Limit extends to 0, a x square e to the power of x minus b ln of 1 plus x plus cx e to the power of minus x divided by x square by sin x equal to 1. Then what is 16 times a square plus b square plus c square? Okay, so this limit is defined and its value is 1 at x tends to 0. That is important thing. So first thing is, if you substitute all the values, basically you can make ab, the numerator also should be equal to 0, right? So how do you do that? If I substitute x equal to 0 here, I'm not left with any terms here actually, right? So b equal to, I mean, you don't get any of them. So only thing is you use the Taylor series for e to the power of x and ln of 1 plus x. These are the series which are given here. I'll substitute them straightforward and see what happens. Okay, so my function definition here will become ax square into e to the power of x expansion here. And how many terms I should take? The denominator highest power is x square, so up to x square is enough. Okay, minus b, uh, this value. Okay, and plus cx times e to the power of minus x. This is the expansion here. Okay, and below I am actually I need up to x cube. Okay, not x square. I need up to x cube actually, because I have a x cube term here in the denominator. Okay, so be careful. I added x and divided by x because to make sin x by x as 1. Okay, that's it. So when I apply limit extends to 0 on this one, it will become, take the terms, common terms carefully. Okay, so this is a x square. So what is my x term basically? There is one cx here. Okay, there is one minus bx. So c minus bx plus, what is my x square terms now? Take the x square terms, a x square. So a coefficient is a, plus b by 2 x square, and yeah, minus c, correct? Minus c x square, so minus c into x square plus x cube term. Okay, if I take x cube term, it will become ax square into x, which is ax cube. Okay, so a, okay, minus b by 3, minus b by 3. Okay, and here it will become c by 2 factorial, which is c by 2 into x cube, and then so on. Okay, so anyway we know that this part will become 0, so I'm not interested. Okay, and if I apply limit here, this will become, okay, I am left with c minus b by x square, correct? And a plus b by 2 minus c by x, and this is a minus b by 3 plus c by 2, and that's it, right? So this also should become 0. Otherwise, okay, otherwise these two basically are indeterminate, right? These two are indeterminate because I have 1 by x square, 1 by x terms. Eh, so if I apply 0, they become indeterminate. So what I have to do is I have to equate c minus b equal to 0 and this a plus b by 2 minus c equal to 0, and this limit is defined as 1. So this is the value of the limit. A minus b minus 3 plus c plus 2 is equal to 1 actually, right? So I just took the coefficients accordingly. C minus b equal to 0 and a plus b by 2 minus c equal to 0. Okay, from this one I can derive b equal to c, and if I substitute that here, it will become a equal to c by 2, and my a minus b by 3 plus c plus 2 is equal to 1. So with all these three equations, I can get my three values: a equal to 3 by 4, b equal to 3 by 2, c is also 3 by 2. So what is my 16 times a square plus b square plus c square, which is 81. That's the answer. Okay. So this is another example of using Taylor series. So this is how you should use. You practice more, you will remember the series. Otherwise, remember the definition, and only the tough series you can remember. Okay. Next. Yeah, that's all for today. This is about the Taylor series mainly and the application of Taylor series methods. Okay. Keep solving maths. I'll come up with more videos. Thank you.